Okay, here we go. So this section is called compound inequalities. And compound inequalities is something that you need to know at the very first part of Algebra 2. And if we don't cover it here, you would never get it. But a compound inequality means more than one inequality. And you put them together. Right, so compound inequality, two inequalities, and they're joined together by a word. It's either and or it's or. So examples would be x is greater than 1 or x is less than 0. That's a compound inequality. Right? X is greater than 2 and x is greater than -2. That's a compound inequality. Right? It's two different separate ones. In order to know whether the whole thing is true or false, you got to consider each part. So compound inequalities. So here's an example, not with math, of using the words and or. If you say, I am going home and I'm going to 7-Eleven, if you go home but you don't go to 7-Eleven, is your statement true? You said you were going to do one and the other, and you did one. That's not true. What if you said, I go home and I go to 7-Eleven? Is it true? Yeah, you said you were going to do both and you did both. What if you said, I'm going to go home or I'm going to go to 7-Eleven, and then you go home but you don't go to 7-Eleven? Did you? Is it true? Yeah, as long as you did one, that's okay. So these are logical statements, right? They're very formal in the definition. So for an and statement to be true, both parts have to be true. Right? For an or statement to be true, just one, it's enough that one part is true. It's okay if both parts are true, but it doesn't have to be both parts true in order for the whole thing to be a true statement. So that's what we have to keep in mind as we do these. So, for example, on these, I'm going to graph the compound inequality up here based on the two separate inequalities. So x is less than -1 would be open circle, shaded to the left. X is greater than 1 would be open circle, shaded to the right. Right? In order for the compound inequality to be true, then only one part has to be true. So what do I end up shading on the top? I mean, as long as it's shaded on one of these here, then it goes here. Right? So I should put open circle there, shade to the left. Open circle here, shade to the right. So compound inequalities, if it's an or, that just means anywhere that anyone was shaded, it goes on the compound inequality. Okay, now if I switch that to an and, in order for me to shade on the top number line, both of the other number lines must have been shaded for those values. So what am I going to put on the top number line this time? Is there any part of the number line where both were shaded? Right? If I'm less than -1, then this one is shaded, but this one is not, so it doesn't go on there. Right? If I'm greater than 1, this one is shaded, but this one is not, so it doesn't go up there. So what goes up here? Nothing. There's no overlap between the shadings, so there's nothing to shade. Right? Okay, now what if it was x is greater than -1 and x is less than 1? Right? Greater than -1 means open circle on -1, shade to the right. Less than 1, open circle on 1, shade to the left. All right, now we're going to shade on this number line only if both of the other number lines were shaded. So between which two numbers does it look like both number lines were shaded? -1 and 1. So this is the compound inequality. It goes from -1 to 1, and it's shaded in the middle. Okay, what if I said or? What if I change that to an or? What am I going to end up shading on the top number line? Remember, since it's an or, you don't need both of them to be shaded. You just need one part of it to be shaded. Okay, should I shade less than -1? Is either one of these shaded less than -1? Yeah, this one is shaded, right? So I'm going to go, yeah, that's a good one. Am I going to shade between -1 and 1? Is at least one of these shaded between -1 and 1? So I got to keep going there. Am I going to shade to the right of 1? Yeah, because this one is shaded. For an or statement, I just need the one part to be true. So what ends up getting shaded on the whole thing, right? One or the other is true everywhere. That's how or statements work. Okay, what if it's x is greater than -1 and x is greater than 1? What am I going to end up putting on this top? Remember, what has to be true for the and to be true? Both. Okay, so where are both shaded? To the right of 1, right? The only place where they're both shaded is to the right of 1. Should it be open or closed circle on 1? It's open, right? Because this was not, 1 was not included in this one, so it can't be included in the compound inequality. And then it's shaded to the right. Okay, what if it's or x is greater than -1 or x is greater than 1? What's going to end up getting shaded on the top? Right? Start at -1 and shade to the right. Okay, because at least one of those was shaded from -1 on. You know, both were shaded to the right of 1, but you only need one, and that's good enough. Okay, so now translate the verbal phrase into inequality, then graph the inequality. All real numbers that are less than 0 or greater than or equal to 2. How do I write all real numbers that are less than 0? X is less than 0. Okay, how about all real numbers that are greater than or equal to 2? X greater than or equal to 2. Now, the word is or. So what does that mean? We need just one to be true for the whole thing to be true. Okay, they said graph it on a number line. Okay, x is less than 0 should be open circle on 0, shade to the left. Should be closed circle on 2, shade to the right. Okay, when I put them together with an or statement, what's it going to look like? The same thing, right? Everything gets included with an or. Everything. Okay, all real numbers that are greater than -2 and less than 3. Okay, how do you say greater than -2? Greater than -2. Okay, less than 3. Less than 3. And these are tied together with an and. So what has to be true? They both have to be true. In terms of the shading, what are we going to look for? The overlap. Okay, so let me graph this. So 0, I got -2 here, I got +3 here. Right, this one is saying it's going to be open circle on -2 and shaded to the right. This one is open circle on 3, shaded to the left. So where do they overlap? Between -2 and 3, they're both shaded. So this is the answer. Shade in between those two. Okay. So try to do that one. You're going to graph two different inequalities on the same number line. All real numbers that are less than -1 or greater than or equal to 4. So we've got -1 and we've got 4. Right? If x is less than -1 open circle, shade to the left. Greater than or equal to 4. Probably should have written this down. X is less than -1, or X is greater than or equal to 4. When I put them together with an OR statement, then that is the graph. Right? They don't have to overlap. You just put together all the areas of shading. Okay, try this one. All right, this is an AND. Greater than or equal to -3, less than 5. Okay, so we're going to graph them both on the same number line, and then we're going to shade, or figure out where they overlap. So, or equal to means closed circle, shade to the right. Open circle, shade to the left. So where do I have to, where's the shading go for the whole compound inequality? Between, right? It says and. Oh, no, you're right. It said or. I missed that.
No, it said and. No, it says and.
Oh, I'm sorry. Yeah, we're looking at this or and this and. It is and. It is and. Okay, so when you get those kind of, when you get an and inequality like that, where we end up shading the overlap in the middle, that can actually be written as a 3-part inequality. And it's written like this. You would say -3 is less than or equal to x is less than 5. That usually when that's the situation, you don't use 2 different inequalities and the word and anymore. You make one 3-part inequality. And what that 3-part inequality means is that the shading is in the middle, in between -3 on the left, 5 on the right. A lot of times students will insist on using the 2 different inequalities, which you can do and get it right. But in math books, you won't see that. They'll always use the 3-part inequality. So we really do need to know how to deal with a 3-part inequality. Right, so here's 3-part inequalities. It's an implied and. You don't see the word and. You just see the 3 parts and understand the variables in the middle of those 2. Okay, so like I said, you should always use these 3-part inequalities if they're appropriate for the situation. If you don't, and you follow everything through, I mean, I'll count full credit for it. But you can't be surprised when what you're presented with is a 3-part inequality and wonder what to do with it. Okay, so here's a word problem. A crane sits on top of a camera car and faces towards the front. The crane's maximum height and minimum height above the ground are shown. Looks like 4 is the minimum and 18 is the maximum. Write and graph a compound inequality that describes the possible heights of the crane. Okay, so this would be a case of if the possible heights are between 4 and 18, that means 3-part inequality. So we would want to write 4 is less than, and I'm going to assume equal to, the height is less than or equal to 18. So that's describing what we see in that picture. Okay, they said to graph it. So if you graph the 3-part inequality, there's the 4, there's the 18, closed circle on both, shaded in the middle. Right, that's a 3-part inequality. Okay. Now, if you get something like that, where you have to solve a 3-part inequality, because it's actually not just a variable, but there's an expression and it needs to be solved, the way you do it is you isolate the variable in the middle part. Like, what's with this 5 that we need to, or sorry, what's with the x that we need to get rid of so that x is isolated? The 5, right? And you're going to subtract 5. But because there's 3 parts, it's not like an equation where you say do it to both sides. Now we got to do it to all 3 parts. So whatever you do to the middle part to isolate the variable, you got to do it to all 3 parts. So minus 5, minus 5, minus 5. Negative 3 is less than x is less than 4. And that's solved because the variable's alone in the middle. Okay, they said to graph it, so we will graph it. Right, it's got a negative 3 on the left, positive 4 on the right, open circle on both, shading in the middle. Have you Connor? Yeah. Yes. I think I've got that on here. I think that might be one of the last slides. Right. So again, you could take that same thing and do it like it's 2 different inequalities. Right. Subtract 5, I would get negative 3 is less than x. Subtract 5. X is less than 4. But you have to, if you do it that way, you have to include the word and. And then when you graph it, you're going to need to show that you're going from negative 3 infinitely to the right, and from 4 infinitely to the left, and that because it's an and, that actually the only part of the graph which counts is where they overlap. So again, you could do it this way, but make sure you include those details. If you do it with a 3-part inequality, you don't need to worry about that, which I would think is better. Okay, try to solve these 2. In fact, just let's solve 1. Let's do number 5. Let's not do number 4. Okay, what was the first step to isolate y in the middle part?
Subtract 4.
Okay, so if you subtract 4 here, you subtract 4 here and here. 3 times. 6 is less than or equal to 2y is less than or equal to 20. Okay, then what? 3 times, right? 2, 2, 2. So 3 is less than or equal to y is less than or equal to 10. Right? And now I'm going to graph that. 3 on the left, 10 on the right, open a closed circle on both, shading between. Right. Okay, and then the last, I'm going to do this one because it's the thing that Connor just asked about. Okay, how do I isolate the variable in the middle of this one?
You gotta add z.
Okay, add 1 3 times. So now we get negative 6 is less than negative z is less than 4. Okay, and how do you get rid of a negative which is multiplying? You could say divide or you could say multiply. Remember, that's the multiplication property of negative 1. It flips the sign. So at the moment that I multiply by negative 1, what do I have to do to the inequality symbols? They flip, right? So I'm going to write negative 1 times negative 6 is greater than negative 1 times negative z is greater than negative 1 times 4. So this is 6 is greater than z is greater than negative 4. Yeah. If you don't flip the signs, you end up with something like 6 is less than z is less than negative 4, which is like saying 6 is less than negative 4, which is obviously not true. So you got to be careful. Yes, it does flip both of those symbols. Still the same rules apply. And if I was going to graph it, negative 4 is on the left because it's less than 6. Even though it's written in opposite order here, it looks like it's open circle on both, and the shading still goes in the middle. That was it.
What the heck was that?